I would like to welcome everybody here to a seminar in the Department of Geology, Geography, and Environmental Studies. I'm Deanna Van Dyke, and I'm very happy to be hosting this seminar. And thank you for coming in this week at a slightly earlier time than our usual seminar time. We've changed the time to 3 o'clock for this week because of Good Friday activities. And I have put into the chat the link if you would like to join the 4 p.m. service today. There's a link to the live stream in the chat. So we're aiming to have this seminar between 3 p.m. and 4 p.m. For today. And so I will try to keep my introduction short so that Professor Higley can have lots of time to tell us about today's topic. I'm delighted to introduce Dr. Melinda Higley to everybody. She is a newer member of my department, but I was privileged to meet her a number of years ago when she was an undergraduate student in our department. And so we're thrilled that she is one of our graduates with a Bachelor of Science in Environmental Geology. And from here, she went on to the University of Toledo, where she obtained her Master of Science in Geology. And she worked in the field, and I actually mean literally in the field for a good part of that for a number of years out of the Prairie Research Institute in Illinois. And then went on to do her PhD in geology at the University of Illinois, did some time with the Ohio Department of Natural Resources after that point, and then we're very happy that she's joined us in our department. And Dr. Higley is going to be talking to us today about some work that she's done previously with an intriguing title, which I just about gave away, but Melinda, I'm going to enable you to introduce your topic. So I would invite everybody perhaps to make sure that your mute is on, and it's up to you whether you keep your video on or off during the talk. There will be opportunity for questions after that. And Melinda, as we turn things over to you, assume a lot of applause coming from the different names that you see who are participating.
I'll go ahead and share my screen while the applause is roaring. Okay, we should be seeing a full lagoon taking over your screen if you so choose.
It looks good.
Good. Thanks, Deanna. Well, I am very happy to have you all join me today on this Good Friday for sharing of this topic that is very dear to my heart. So today I'll be talking about climate hydrology and the problem of fresh water in the central tropical Pacific. And really, climate and hydrology are part of the problem of fresh water in the central tropical Pacific. So all these things are necessary to understand this particular topic. So I'd like to begin by just telling you about my approach to this particular topic. And if you'll entertain me that while you stare at this beautiful lagoon, that would be great. So I'm a geologist through and through. I've always studied geology, and all of my degrees have geology in the title. But yet I'm here talking about freshwater problems. So my interest in this is really because my research questions have to do with the history of the water cycle on Earth. And what that means is that I investigate environmental conditions on Earth from past times, and I look for clues about how wet or how dry or how windy or how stable or unstable or how glaciated or unglaciated, etc., a particular location was in the past. And then I try to tie that together with what is happening or what might have been happening regionally and the atmosphere for that location, and think about the implications for that globally. But what I've been finding over the years is that that kind of research just naturally ties in with concerns over the water cycle as we can understand it today. After all, one of the reasons we try to understand anything in any field or understand the past in any field is to try to prepare for the future on our planet in that particular field. So if you would join me, I'd like to investigate with you today a very important part of the world that I think often don't think very much about, that seems very far away, but in terms of global circulation patterns is extremely important for us here, even in Michigan, or wherever you're watching from, of course. So let's head to the Central Tropical Pacific. What we're going to do there is I'm going to give you a little bit of background about the Republic of Kiribati, and by way of geography, a little bit of culture, a little tiny bit of history, and hopefully that will lead us to what I'm calling the freshwater problem there. And then we'll have to talk about the hydroclimate of that part of the world. And we'll talk about geology and hydrogeology of coral atolls, and then a little bit about what we can learn from remote sensing for island hydrology. So you'll get a lot of information today that is just kind of general about geology and hydrogeology, but specific to the Republic of Kiribati. So I'm going to start off with a bunch of pictures because I've been to this location. Like Dr. Van Dyke mentioned, I've done field work in the Central Tropical Pacific. So on this first map, I'm going to guide you to where we're headed. So on the map on the left, we're seeing Hawaii. So there's Hawaii. That's our launching off point for getting oriented, and quite literally, if you want to go to the Republic of Kiribati, you probably have to fly to Hawaii first. And then you can fly from Hawaii down into this hammerhead shape where the international date line does this funny thing, and it kind of wraps around the Republic of Kiribati, an entire nation of islands. So that same hammerhead shape can be seen over here on the right-hand side. So there are many island nations, actually. Kiribati is just one of them. So we could do some extrapolating about the problems there, the problems in Kiribati to other places, perhaps. But this nation particularly straddles the equator, and so it brings about its own set of particular hydroclimate context and issues. So here's another map that gives us some more orientation. This is more of like a little travel brochure type map. But what we're seeing here is there's that hammerhead shape again of the international date line kind of wrapping around all these islands. And we have 3 sets of islands that comprise this nation: the Gilbert Islands, the Phoenix Islands, and then the Line Islands. And I'll give you a couple of examples from these different island pods today. The blow up maps up top are for the Tarawa Atoll, which is right here. And then there's the Tarawa Island, which is part of the Gilbert Islands. That's home to the capital of South Tarawa. And then they're also showing the Christmas Island, or Kiritimati, and that happens to be the largest island amongst the 33 islands that make up this nation. On the left, we have pictured the flag for this country. And what's special about it is that they're showing I think it's the frigate bird, if I remember correctly, flying over the setting sun. And I think I also got a picture of one myself flying over one of our research boats at the time. So it kind of has that same gestalt going on in the flag as it does in my picture. So there's a lot of seabird nesting territory in this part of the world, and it's protected and considered very important. This country has a population of about 120,000, and that number is growing. It's going up. Most of that population lives over here in the Gilbert Islands. About half live in the Tarawa Atoll, which is composed of several small islands. So it's a lot of people on some small strips of land. All told, the average height of this nation above sea level is about 2 meters. So not only do we have a lot of people on small strips of land, but they're all living on average around 2 meters above sea level. So you can begin to assume that there are some problems associated with that height above sea level. So now I'd like to show you some pictures from Christmas Island in particular, the big lobster-shaped island, because I've been there. But this is a way of giving you a little bit of a cultural tour of this country. And I do know that a lot of what we see culturally on this particular island is shared amongst all the islands. So despite the very large swath of latitude that is taken up by this nation, there's a lot of commonalities for just culture. There's a lot of people movement back and forth between the islands. So what you see in these pictures is very representative of many of the other islands. So just take that with you as we look at some of these pictures. But otherwise, welcome to Christmas Island. This is what you see after you step off of, believe it or not, the 747 that flies to Christmas Island. And you're welcomed by this particular airport. And it's quite a sight to behold, to stand in line at this airport. For me, it was one of my first experience flying to a developing nation. So seeing this airport was quite a shock. Pretty interesting place. This is where you land. Oh, and if you're on the plane to Christmas Island, the other people that are going to be on the plane with you are other people who live on the island, who are moving between Hawaii and Christmas, either because they're Mormons who are coming back from one of their excursions abroad, or maybe they're a politician or a diplomat or something along those lines. Usually those are the people that are traveling around. The people on the island are pretty poor, so there's not a lot of people just flying for fun to someplace else. It's very expensive to do so. You'll also see a lot of fishermen. That guy for sure was a fisherman. You can tell by the way they dress. So you've got a lot of fishermen that are going to be on the plane with you, doctors, missionaries, and then probably a few scientists like us. And that's about it for the people that are going to be on that plane. When you are on the island, you'll notice immediately that life is lived outside. You'll just be hanging out under the trees for the most part. And even when you are inside a building that is maybe sort of like a hut with a coconut leaf roof, it sort of feels like you're still outside. It's just a very airy, breezy, warm place to be. And people walk around barefoot all the time on these sandy paths. So it's just, life is outside. It's very delightful. The dogs take advantage of that. It's a very common sight to see dogs wandering around. You never know who the owners are or where they've come from. But there's a lot of dogs on the island. And I love in this picture how they're just sitting there gazing out onto the ocean, or out into the lagoon in this case, just seeming to enjoy themselves. Chances are they're also just waiting for their owner to come back from a fishing expedition of some sort. So lots of cute dogs, and lots of trash on the landscape on the coastline, especially. That's a pretty common sight. We see a lot of interaction with the water, with folks who live on the island, just playing sometimes, or a lot of times having some sort of task at hand. There's a lot of times some task oriented with seafood. I'm honestly not sure exactly what folks were doing in this picture. I think my husband Aaron took it. Maybe he can enlighten us at some point when we get a chance. But people playing around in the water or conducting their business in the water is a pretty common sight. We also see a lot of coconut products being used on the island, grown and used. So coconut is one of the only agricultural products that comes from Christmas Island. It's an export of sorts. It's not a lot of export, but this would be one of them. They dry the coconut shells or the coconut shells and the coconut meat for export. Something you could get if you were on the island is also a coconut liqueur of sorts that is, in this case, being stored in an old oil jug, cooking oil jug. You might be lucky to get your hands on a fresh coconut that could be cracked and the liquid extracted as well. So it's pretty common to see coconut stuff on the island. The trees are an interesting groundwater interaction because coconut trees are very thirsty. And so they do soak up a lot of water resources. And they have a lot of coconut trees on Christmas Island. There's a lot of coconut stuff. There's a strong presence of religion on the island. There are lots of different denominations and different churches represented. I think this one was one of the Catholic churches, but you would see Catholic churches, you'd see Protestant churches, and a lot of Mormon churches, several different large church buildings in the different villages on Christmas Island. So it's very common to see people interacting with their church structures. And likewise, there is all these cool cemeteries that have a lot going on. So if you go to a cemetery, you're going to see this really strong connection with the dead on the island, and you know, that including like little flagging and little huts over some of the graves. And then the vaults themselves are set very shallowly in the ground because of the high water table activity on the island. So these graves actually also become a source of groundwater contamination for interacting with that high water table. So I'll start alluding to some of the freshwater problems that we see just walking around. The island has some really fascinating history, and I'm just going to focus on one particular aspect of it. So in the Cold War, when we were busy trying to do hydrogen bomb testing in the tropical Pacific, Christmas Island was a very important depot for that kind of activity for both the Americans and the British. And I have a little excerpt here. This is a bulldozer. This is a clip from a propaganda film from the 1960s declaring how cool it is that we took over this island and raised it to build camps for our soldiers so that we could test hydrogen bombs. Anyways, yeah, so the propaganda videos are hard to watch, but nonetheless, the evidence of all this activity is on the island. You can find it. My friend Christina and I, Dr. Karen Paradu, she and I found casings from bullets, and if you look, if you get a complete one, you can see that some of them are Japanese actually, and some of them are American. So there was a Japanese presence here as well. And this is a picture taken off the wing of a Royal Air Force plane showing what one of these camps would have looked like. This is not here anymore, but this is what a camp would have looked like for all the soldiers housed to help run this operation for hydrogen bomb testing, which was called Operation Grapple. And then on the right-hand side is a picture of one of these tests that was detonated at night. It was not very common for the tests to be detonated like on land. Usually they were done with a balloon or off of dropped from a plane offshore, but this was one of the closer ones. So pretty interesting history of human occupation on the island in its past. So let's move on to this idea of the freshwater problem for this nation of Kiribati. I've got a couple pictures here. One is rainwater storage, which can be found in giant cisterns for pretty much every household on Christmas Island. And on the right-hand side, we have a smaller tank or cistern sitting atop of this pole. Actually, it's a pump. Anyways, you can draw water up through there and bring it into the cistern. And what we're seeing there is groundwater being use to fill this tank. So we have two totally different forms of water storage, both very important for life to subsist on this island. Now, the rainwater, believe it or not, is very seasonal. And you would think with a tank that big, it would be a really important source of water storage. But the reality is, on this island, groundwater becomes much more important for regular water use. And so the way this operates is we've got these huge tanks which get filled with rainwater during the rainy season, and then they're kind of there for basically emergency use. But the groundwater gets pumped once a day into these small tanks from the city well field. So it's essentially the city water system. And this tank will get filled, and then you have until the next day to use all that water and then have it be filled again. So if you're taking a shower, which that's where that water would come from, or flushing the toilet or doing anything like that for daily use, it takes on a whole new meaning to say, hey, I'm going to drain the tank. It's not going to get refilled really until the next day, or the pumps have to be turned on in order to fill it. So it's a very, very limited resource, both from rainwater, which comes from draining off the roof, or from groundwater, which gets pumped into that tank. So water supply is very limited. I think you can tell just by looking at those tanks. So I'm going to highlight a particular article that came out in Nature in 2015. And this particular article really did a nice job of laying out the issues being faced in tropical islands in terms of fresh water. So this is based in the idea. The premise of this article is for us to be aware that sea level change is something that is happening in the world. However, sea level change may not be the thing that actually causes displacement of people from these islands. In fact, it's more so the issue of things like tidal fluctuations, things like king tides coming onto the land. So this is sort of related to sea level change, but it's more isolated incidences of tides overtopping the land surface, and storm surges, and things like these kinds of one-off events that are potentially causing contamination to water resources. So that's why we have this title of the article, which says, before we drown, we may die of thirst. And so what that means is sea level rise, whether that's a long way off or not, is not going to be our limiting factor. The freshwater resources may become damaged or polluted or irreparable for whatever reason before the sea level physically overtakes this average of 2-meter high island nation. So that's the premise of this particular article. And honestly, this article inspired a lot of my own personal thinking about this location and some of the importance behind some of the research I ended up doing, which I'm going to show you a few minutes of at the end. So here's a picture from that same article demonstrating that in these mega tidal events, where the tide range is so high that lower portions of some villages become completely submerged, that during these high tide events, all the seawater, which in itself is acting as a contaminant potentially because it's salty, also has human waste in it and animal waste, and the wells in the villages can actually become submerged and ruined during events like this. Despite that, the kids look like they're having a great time. So they're a happy people, and there's some solace to be taken from that. Okay, so here is an example from Batia. This is a small island in the Tarawa Atoll, so way over to the western portion of the country. And as of 2009, when this article was written about this particular location, this island was becoming uninhabitable due to polluted freshwater reserves. So despite the fact that we have 15,000 people per square kilometer on a strip like this, there's no way to sustain life when you have to abandon freshwater reserves due to pollution. So Batia is essentially a bellwether for the situation in Kiribati as a whole. Now, Christmas Island is much larger, but yet the population is smaller. So Batia is a pretty good example of what life is like for a lot of people in Kiribati over there in the crowded Tarawa Atoll. So here's a takeaway from that, is that Pacific atolls may become uninhabitable before submergence by sea level due to irrecoverable groundwater pollution and salinization. Okay, so scientifically, the jury is still out on whether sea level rise will end up consuming tropical islands. And there's a lot of science reasons for that. But like we were saying, the threat, the more considerable threat is loss of groundwater resources. And this table helps to explain why that might be. So now this table has a lot of details, and I've simplified it for us, but the full-on table, and I've got a clip of it down here on the right-hand side. So we could look at the fuller version of that table if we wanted to. But looking at the simplified versions, what we see, that, by the way, this is geared towards small island nations. This isn't just oceans in general. This is specifically threats to small island nations. There's very few reports out there that get that detailed for small island nations, but this is one of them. So we see that as one of the climate drivers that we're concerned about, sea level, or one of the drivers of problems, excuse me, sea level rise is one of them. And one of the effects of sea level rise that we might see on the island is submergence. Now, as far as the trends and projections, the way these are colored is that, well, with any trends and projections, they always come with what assurance we have that the models are in what the models are trying to tell us. So a dark blue arrow is an indicator that there is high confidence in the consortium of models that give this information. So for sea level, there is high confidence that the trends of sea level are increasing and that it's projected to keep increasing. So that's how we read across this table. The next major driver here is storms. And the effect of storms is coastal flooding. It wasn't too clear cut what the trends and projections were with storms because of limited observations. So this is not a good example, but storms are problematic. It's just that their problematicness is very contained to certain areas doing certain things. Winds, with the effect of storm surges, we have low confidence in the models that, but the direction is that the winds will increase in their speed over into the future. We have waves, which result in coastal flooding and erosion. The trend is high confidence that they will increase, and then the trend with low confidence is that the projections is that they will increase. And then we have extreme sea levels, which are related to tidal issues and things like that, which can result in coastal flooding, and then saltwater intrusion from below. And you can see that both trends and projections are increasing there. Sea surface temperature, which is has implications for overall global circulation changes and coral bleaching. The trend is that the sea surface temperature is going up, and the projection is that it'll go up. Freshwater input. So the rain coming down from the sky. The effect of that is that we can get an altered supply in places where we've typically counted on it in the past. The trend is that that is decreasing. The amount of rain is decreasing in the tropics, and that the projection is that it will continue to decrease in the tropics with medium confidence. And then finally, ocean acidity is another driver that can result in decreased pH for the ocean. And we've got high confidence that it's on its way up and that it will go up in the future. So that was a long table, but all these things contribute to fresh water being altered for any place in particular in the tropics. So I like to point to extreme sea levels as kind of a thing to hang our hat on for today, and freshwater input for both of these things potentially changing. For this really matters for Christmas Island, especially in coral atolls. So I'm going to explain some of the geology and hydrogeology behind why this matters. One more related thing about this, this has to do with the high-low confidence part. This is a map of climate warming scenarios. So we've got two different scenarios, the left-hand side and the right-hand side. One is lower, one is higher in terms of scenarios. And then for the top, we're looking at temperature. And for the bottom, we're looking at precipitation. And what I want you to see here is that there's a difference in patterns covering the globe. The stippled pattern for the temperature indicates that these models, we have confidence in them that and anywhere where there's a stipple pattern, that we understand that these scenarios could happen. Now down here in the precipitation pattern area, excuse me, the lack of pattern in the central tropical Pacific, this kind of empty pattern, is an indicator that our models don't agree on what's going to happen in these places. So it's like big question mark on what is going to happen in the central tropical Pacific under climate warming scenarios. We don't know what the outcomes are going to be. So, more research is needed, of course. So let's talk a little bit about the hydroclimate in the central tropical Pacific so we can understand all of these implications for, I told you earlier why the climate matters for us here in Michigan, and just why do we care about what's going on in the central tropical Pacific? So I specifically mentioned hydroclimate. I'm going to focus on the water cycle part of climate. I'm not going to talk a lot about temperature averages or anything like that. It's warm, it's nice, that's all you need to know. But in terms of a hydroclimate, things get pretty wild. So what we're looking at here again is the Pacific Ocean. And we're looking at this prominent feature, a band of clouds that goes all the way across. This band of clouds is is showing us where the intertropical convergence zone is. And this is a zone of convection. And we're seeing also that there is consistent precipitation that goes along with these clouds. So this band is a zone of consistent precipitation all the way across the tropics. And it hovers right around 6 degrees latitude, but it changes seasonally. So it dips down and goes back north. So it dips north and south over the course of the year, taking the rain with it where it goes. So that's one big part of hydroclimate in the central tropical Pacific, is this perennial band of rain. It goes around the globe, but so it's not just in the Pacific that we see this phenomenon. And I should have highlighted it for you. We've got the ITCZ has the dashed line, and then we have the equator to show you that it just sits just north of that, and then our area of concern here is in blue. The other important phenomenon in the central tropical Pacific that really dictates a lot of how we see precipitation falling and where and when we see precipitation falling is the El Nino Southern Oscillation. So this is a climate phenomenon that happens every 2 to 7 years. And what we see is a change every 2 to 7 years in where the warm water of the central tropical Pacific is relative to areas of colder water. So normally, here we've got the western part of the Pacific Basin. It's warm there, and normally it's cold over here by South America. And that thermal gradient sets us up for the trade winds blowing across the Pacific Ocean. So we get this cycle, or this thermal cell, where it's always raining over in the Western Basin, closer to Indonesia, and then it's usually kind of dry over here. Now, during an El Nino event, the trade winds sort of break down. And when they break down, this whole cell of rain shifts to the east. And Christmas Island ends up getting dumped on during an El Nino event, because this whole cell shifts and parks over Christmas Island and that whole zone of the central tropical Pacific. So we get these anomalous precipitation events every 2 to 7 years. By anomalous, I mean it rains a lot more than it would normally rain in the yearly rainy season. So there's sort of a yearly rainy season due to the intertropical convergence zone, but this is like way, way more rain. And some El Niños are bigger than others. So we can get anomalous rain, or just anomalous rain from El Nino. Now, La Nina is the opposite. La Nina happens when this whole convective cell ends up getting pushed really far to the west, way over by Indonesia, and then Christmas Island experiences severe drought when there's La Nina, because basically this zone of pressure parks over Christmas Island and it becomes very dry every 2 to 7 years. Can't really predict it when that's going to happen. Okay. So droughts become these frequent events. For Christmas Island, it's associated with La Nina, and this becomes frequent events over the Pacific Ocean for a lot of these island nations. So we have got some instability in our freshwater access. And finally, global rainfall patterns are deeply affected by this El Nino La Nina pattern. So just wanted to point out that we can see this over here in the Midwest as well when El Nino and La Nina happen. So it's not just the central tropical Pacific that is feeling the effects of this climate pattern. It's very important for all of us. Let's talk about the geology and hydrogeology of these atolls. So this is a map of the northern Line Islands. So there's Christmas Island down there. There's that cute little lobster shape for the island. And then there's a couple more islands in the line, including Fanning, Washington, Palmyra, and Kingman Atoll. Now notice they get smaller to the northwest. And this is because this is an extinct volcanic ridge with a classic hotspot-like pattern where the hotspot, it was more recently under Christmas Island than it was under Kingman Atoll. So all of these islands have volcanic rock basalt at their core. Now, since the volcanic ridge has gone extinct, these islands have been subsiding. And as a result of that subsidence, the coral life that grows on top of the basalt core grows higher and higher to keep pace with that photic zone. So we end up with a thick sequence of limestone from all the coral on top of basalt. The basalt is so far down, you can't even get to it hardly. I mean, even the drilling cores that I've seen from the islands usually don't even have basalt in them. Usually because they're going after hydrogeologic resources and don't care about it anyways. But yeah, it's like meters and meters down under the limestone. So that's the big picture geology for these islands. Extinct volcanic ridge. If we look closely at Christmas, we can now see that this island is covered with about 500 different lakes. And each of those lakes is essentially a little pocket of sitting in dissolved limestone. So the whole island is just like a holy limestone surface. And it's just pocketed with all these lakes. Now, if we look at some of the variety of geology on this land surface, all these different lakes, some of them are brackish, some of them are hypersaline. They all sort of go through this wetting and drying cycle over the course of the year. Oops. There are sand dune fields on the island along the higher rims. That dune sand is just full of sand that it comes from coral parts. There's no quartz or silica on this island. It's all calcium carbonate sand. That's little coral, even little pink bits of coral sand, and little echinoderm spines, and just full of biologically rich sand. And then the rest of the island is basically this scrub landscape with a nice hard pan kind of calcium carbonate crust. So that hard pan calcium carbonate crust with the scrub, that is very commonly what you would see if you were looking at a cross section of the island. You had to place that somewhere. It'd be right about here in this flat space. So looking at this cross section, we're now bringing in the idea of freshwater on the island. So we've got our freshwater lens, which kind of sits there floating on top of the salt water that is saturating the lower parts of the island. So the lower parts of the limestone, and then of course the basalt under that. Now, the way this image is drawn, we're seeing these black arrows going downward from the what is like the holes, the dissolution pockets that these lakes are sitting in this generic cross section. We're seeing these arrows kind of drawing down. That's to indicate that rainfall falls on the island and then soaks through the ground and recharges the freshwater lens. So those recharge zones are like that scrub brush area. Then we also have this slightly higher rim on the island, which is greatly exaggerated in this case. If we were to take a cross section of Christmas, if we had proper vertical exaggeration denoted, it wouldn't look that big. The highest part of the whole island is 10 meters, and that's a huge, huge sand dune. Okay, so that freshwater lens, which is floating on top of the saltwater, because freshwater is less dense than saltwater. Really, it has, it's not this cut and dry line between the two. We can see this in this example from Bunriki Island. Some of these islands we have some pretty good data from studies that have been done a long time ago. In this case, what we're seeing is conductivity values for the freshwater and then the saltwater. So you can tell where the freshwater is because the conductivity values are 2,500. And then we can tell that we transition into saltwater because the conductivity values become much higher. So over the course of this space, over the course of 5 meters or so, we go from freshwater lens and into the saltwater. Now this matters a lot because if you poke a well down into the freshwater to try to supply your village with fresh water, you have to really be careful about where that well is going and how deep, because you don't want to draw into the saltwater. So that's why we have some data that looks like this to try to hone in on where that boundary might be. Now that boundary fluctuates a little bit. And here's a good idea about why that is. These are core samples from the very porous limestone on Christmas Island. Now, again, I'm switching back and forth between islands because there just isn't that much data. So I'm trying to pull examples from relevant places where it exists. But this is limestone from Christmas Island. If you notice all of these black holes, those are actual holes. And so this rock is very porous. Very porous rock lets water be transmitted through it, typically very easily, as long as those pores are sort of connected to one another in some way. So with the limestone of Christmas Island, we have high porosity values. Now, high porosity rock can be a very good aquifer, but with a lot of water traveling through it. But the thing is about really porous rock and good aquifers on coral atolls is that saltwater can do the same exact thing. It can transfer through the rock just as easily as the freshwater can. So it actually becomes a bit of a liability to have this very porous, water-rich rock being part of the aquifer. Here's proof of that. This is a data set, particularly for my hydrogeology students who have joined us today, because they'll know what this means. But we've got a histogram here of hydraulic conductivity ranges. So hydraulic conductivity is a measure of the velocity of the water through the subsurface. These values are very high, 7 to 14 meters per day measured on Bunriki. That's like really fast water moving through the subsurface. It's probably about the fastest on the planet. That you can move a lot of water through the system, which means you can't hold on to it necessarily, can't keep it there, and salt water can do the same. So here's an implication of that and a measurement of that as well. We can see the water table and the tide are plotted on this graph, again on Bunriki Island. So two different points of measure. One is the red line is measuring the fluctuation of the tide nearby, 280 meters away, from a well, which is measuring the height of the water table in the well. The height of the water table in the well fluctuates up and down daily, or maybe twice a day, because of the tide. The tide is coming from the ocean, but the tidal waters, just like the ocean water, infiltrates in the aquifer underneath that freshwater lens and lifts it up a little bit every day and then drops it down a little bit every day. So that's what we're seeing measured here. So the ocean, this is a direct evidence that the ocean is interacting with that freshwater resource, not mixing with it necessarily, but certainly a little bit in charge of the water table in this case. So this is a picturing that same process. So we can see in diagram form, the tidal signal infiltrating through the aquifer, both in the upper zone and in the lower zone. And there's our transition zone where freshwater becomes saltwater. So we're getting all this interaction. So to summarize these freshwater problems, we've got drought. And these are frequent events every 2 to 7 years at least, in terms of the big ones, on small island nations. This happens because of the El Nino La Nina cycles, or oscillation, excuse me. We also know that freshwater input is kind of projected to change and is changing. And so that's because global circulation is projected to change and is changing. Now, what is that going to look like for the Central Tropical Pacific? Sort of open-ended question. We also know that the freshwater lens for any of these islands is, by definition, is thin. It's just floating in that a little available, 1 to 2 meters of land space on top of that salt water. It's buoyant on top of the salt water. It's contained within porous rock, and it is vulnerable to contamination both from above, from those overtopping events, which are filled with anthropogenic waste and salt water, and it's also sensitive to contamination from below, from the salt freshwater transition level changing due to the tidal fluctuations, changes in sea level, And then, of course, I didn't show a picture of this, but the actual pumping activity within the wells. So I'd like to just end with some comments on how this is not all inclusive, but my thoughts on how research can address some of this freshwater problem. And this comes back to my own research approach to things, which we can summarize as, we know the Earth's climate is variable, but the question is, how does the hydrologic cycle respond to that variability? So unfortunately, this is not easy to do. This is not easy research to do. If you try to do it boots on the ground style, you run into problems. So it's very difficult to do boots on the ground research in these remote tropical islands. Here's just, I could go on and on about how hard it is. I'm gonna just give you the case in point of the broken down truck. You can see over here, we've been broken down for a bit. My husband, Aaron, has gotten out a chair and is reading a book. My PhD advisor, Jess, is asleep. My other committee member, Brandon, is daydreaming, as he often does. The muffler or something is off and on the ground, and our driver is under the truck with the one crescent wrench that he had. He somehow fixed it. We were very many miles away from the village at this point in time when this happened. The point is, things break down and the work is not easy to do. It's very remote, it's very difficult. Here's another breakdown scene. Broken down on a boat this time, stranded in the middle of the lagoon, trying to do hydroclimate research. My PhD advisor is asleep again, and yeah, everybody's asleep but me. I was too worried about trying to finish my dissertation to sleep. It's too much chaos. It's like, we got to get this data collected. Can't sleep. So one potential solution to this is remote sensing. So with remote sensing, this is a subset of data that ended up being a part of my dissertation. So this was work that was a lot of fun to do from behind a computer, although I was missing being on the island at this point, I will admit. With remote sensing, we can capture changes on the landscape. And with USGS imagery, this is an example of seeing the effect of a huge El Nino event on the landscape. It may be kind of hard to spot at first, but on the left-hand side, we're looking at a dry period on the island. So like if you look at this little area right here, there's a lot less blue covering the landscape over here than after the El Nino of 2015, where there's a lot more blue. So a lot of the landscape becomes completely inundated. And if you kind of look, like the little spines of land are all just smaller on the view on the right-hand side. So we can see these changes of one El Nino event on the landscape with remote sensing, with Landsat imagery. So we can calculate those changes using different indices. So we can map this with our fancy colors and get data sets from these kinds of events. So I have an 18-year data set of surface water change on the island, and that's plotted here. So all these little dots are times of surface water being measured on different spots on the island, and it's being plotted against different parameters like this index for El Nino, sea level, precipitation, and evaporation, trying to evaluate what is influencing the what part of the climate is influencing this island. Can we even figure it out? So that's the comparison there. If you make scatter plots of data like this, it kind of helps bring certain things to light. And so some observations that I will throw out for you today. If we look at how on the left-hand axis of all of these plots, we're seeing increase in surface water area. So this WL ratio is a little proxy for surface water area. It goes up with higher values. And then on the bottom, these same indices that are trying to tell us something about the climate in the region. So for example, the precipitation anomaly. I could draw your attention to these high values in the upper right-hand corner. These are data from the 2015 El Nino event. So precipitation is very high. Surface water area is also very high on the island. We get some points like this for sea level. As it turns out, sea level also raises when there's an El Nino event, partially because of thermal expansion of the waters around the island. So we get sea level rising, lots of precipitation. There's just lots of water. So a couple points that we could maybe draw from this is that one thing is that El Nino increases surface water on the island more than La Nina lowers it. Because remember, La Nina makes drought. And we know that because these precipitation anomalies are very high, whereas the drought anomalies are low, but not that low. So that's a yay for surface water, fresh surface water being stored on the island. We can also see that anomalous rainfall events over here on the right, they increase surface water, but then sea level can drop off after the El Nino event, and surface water storage on the island can remain high. So that's kind of another yay for freshwater storage on the island. So that's just a couple of examples of what we can dig into with some of this data that comes from remote sensing to try to understand the implications and the magnitude of these events on freshwater resources. Now, it's not a direct measurement of the interaction between the groundwater and the surface water, but we can make inferences about what is happening with precipitation on the surface of the island. So there's more work to be done there to try to make a lot of connections about groundwater storage, but we've learned something about what climate does to the freshwater resources for sure. So with that, I'm just going to summarize that we saw that the Republic of Kiribati is a growing nation dependent on groundwater for their fresh water. That groundwater resources are highly vulnerable, especially due to salinization, and that the hydroclimate of the central tropical Pacific creates seasonal and interannual dry spells, which limit the freshwater resources for the people of the island. And that remote sensing is one way to study climate and freshwater resources for remote islands if you can't be boots on the ground. And I'll leave it there. Thank you very much for joining me for this topic today. And I'll be happy to take any questions.
Thank you so much.
I see the wild applause.
Oh, yeah. Thank you so much, Melinda. And yes, there's definitely applause going on behind the scenes here. We have some time, some limited time for questions. And so if somebody would like to ask a question, you can do that directly. Just unmute yourself, perhaps turn your video on, or you can put a question into the chat and I'll keep an eye on that. And Melinda, perhaps if you can stop sharing your screen, then we can see whether there's a question from the audience.
Steve Steenwijk.
Yes, go ahead, Steve.
Yeah, thank you for the talk. It's very interesting, a part of the world I've never seen and perhaps never will, but I may get to Hawaii yet someday, I hope. It's on my bucket list. Anyway, my question, well, I have a couple of them, but I guess one was, I was a bit surprised to hear that the local sea level goes up during like El Nino. And I was wondering what the magnitude of that rise would be, like in meters, for example, or fractions of a meter during an El Nino event, and wondering why doesn't it just flow away from the island if it's higher than the rest of the average water level?
Yeah, that's a great question. So the sea level rises of tens of centimeters, half a meter, approximately during an El Nino event around the island. Or around, it's not around the island as much as it is the whole
Right.
body of water underneath where El Nino is happening. And it happens because El Nino creates sort of like it like piles up the water where the event is occurring, because the winds are organizing the water in a certain way. So during an El Nino, sometimes the wind blows a little bit more from the west, whereas normally the trade winds would be blowing from the east. So the wind is kind of fighting against, it's going in the opposite direction and sort of stopping the water from flowing to the west.
Okay.
So it sort of piles up like a hill. And the other thing is the water is warmer during El Nino during that time. So the thermal expansion is localized to the event.
Yeah, I guess the thermal expansion part, I would have thought it would just kind of even out anyway and flow away, but
It turns out the whole Pacific has different levels of water height. So like on average, ignoring El Nino for a second, on average, the water level is higher in the Western Pacific than in the Eastern Pacific. It's just like persistently sort of piling up over there because the trade winds are usually pushing the water to the west.
okay.
So oddly enough, water does not just flow into this even level all around the globe. I actually don't know the physics of it beyond the piling based on the wind and the thermal expansion. But it is not an even height anywhere in the world. And that's part of the reason why studying sea level change is so complicated, because with all these different points of reference, you have to gauge the sea level change based on like these individual points of reference rather than making a global declaration, because it's unique to different basins within the Pacific Ocean and the Atlantic Ocean.
Well, thanks. I'll let somebody else ask and then maybe come back in later.
Okay, thank you. I think I got the hill terminology from Professor Steerley.
Well,
If I can add, it seems like, if I remember rightly, you can do topography on the sea surface out there.
Mhm.
And normally, under normal conditions, it's like 2 meters higher in the west around New Guinea than it is around
Yeah.
Peru.
really?
And it's just because of that piling effect.
Mhm.
I know that happens in a sense, it even happens in Lake Michigan. I mean, depending on wind and weather and air pressure changes. My wife's parents used to live on Lake Makatawa, and depending on the weather and winds and whatnot, water could definitely be pushed. As I remember when they had a particularly high water level year some years ago, and then a weather event caused whitecaps to be bashing into their cellar door. So
Mhm.
I had a question for you, Melinda. Before the Pacific Islanders there had substances like plastic and metal to build above ground cisterns, did they even have above ground cisterns, or did they depend upon like shallow wells dug before that time? Or below ground cisterns or something like that?
Yeah, I think the shallow wells go back much further than the idea of cisterns.
Mhm.
And keeping in mind that people have not been living there for that long. I mean, long enough to need cisterns and methods without plastic, of course, but you know that people have only been inhabiting since the 1800s. And there's some anthropological evidence that people inhabited about 1,000 years prior to that, but there's this weird gap in time that we think like nobody was living on Christmas Island. And
Wow.
by we, I don't mean we, anthropologists. But yeah, so right. I believe that the idea of a shallow well goes pretty far back on Christmas Island, but that dramatically assumes that the water table is cooperating. I think this is also partially why population on Christmas actually is not very high. I think the water table might, because it's a bigger island, actually, the water table might be harder to access than some of the smaller islands. I'm actually just totally speculating about that. But that's a good question. I never even thought about it really before you asked what you would have done before a rainwater cistern. I mean, I'm sure barrels and whatnot would have been used, but how efficient that would have been. I don't know.
You made the point that the underground supply is much more considerable, and so it may have just been sort of a trivial question. Just got interested.
Cool.
Yeah.
Yeah.
And expanding outward on it, though, I mean, these island chains are not unique. There are thousands upon thousands of low-lying, forget the high volcanic islands, but thousands of low-lying islands with what, maybe 2 million people, something like that, 1.5 million people spread across the central and western Pacific. And there's a very real threat to a significant chunk of humans out there over the next just century, right? Do you want to comment on that?
Sure. The nation, or the Republic of Kiribati, has made the news in the last 10 years or so several times for being, they're kind of claiming, I guess, that being the world's first climate refugees. They have purchased part of Fiji so that people can start moving there, because they see they've got a serious problem that people can't continue to live on these islands.
Wow.
Yeah, so they're becoming, they're trying to live elsewhere. But in that article, the one that I highlighted from Nature 2015, there's a quote in there that is just spine chilling, actually. There's a lady who, so the reporter asked, something like, where can you leave when these tidal events flood your home? And I guess they said that she basically laughed and said, where would I go? And it's true. I mean, you can't just get on a plane and leave, not unless you're wealthy and live in one of the islands that actually has an airport, which is like one of them or two of them. Yeah, where would you go? Unless your nation physically up and relocates you, I guess.
Wow.
Yeah.
Thank you. I'll mute myself again.
Melinda, do you have a few more minutes for questions?
Yeah. I was the one that talked into all the way until 4, so let's keep going.
Okay, excellent. I'm not sure if Steve is still here. He had said that he had some questions, but I'm seeing in the chat we've got a question from Benji, which says, what are island nations doing in response to rising waters? Is there an exodus, so to speak, of populations from the islands? He does say that you may have just answered the question, but I'm imagining that Fiji, what they purchased in Fiji might have been a very small amount of land compared to what they currently have. So are there other things that they are doing as well?
They are still investing in water projects. So they are trying to improve what infrastructure there is on the island. And I say that because I saw it last time I was there. I saw one of those projects underway. It was an Australian company, that was digging a new pipeline, groundwater pipeline to transfer the water. It was like a lateral piping storage type system. At the time, I didn't ask enough engineering questions. I was very concerned about the fact that there was a huge hole in the ground and that the geology was exposed. So we made friends with the guy with the backhoe real fast and got on site. But I forgot to ask all the engineering questions. But he was very excited to have 3 geology students so enamored with his hole and his machinery. So we got all the information we needed from and all the samples we needed. But yeah, they're still working on infrastructure. So I mean, they are trying to go that route as well.
Mhm. Is any of the infrastructure, is that building up, such as raising buildings onto pilings or kind of stilts, or?
They do that already. Yeah, they have huts on stilts already.
Okay.
This was like trying to get water out of the ground still. So it was like a special system that instead of having the well go vertical into the ground, it was like horizontal.
Hmm.
And it's just barely in the water table. I'm not sure I totally understood it, but yeah, it was in the ground infrastructure.
Okay. I see that Steve is back and has a question.
Yeah, sorry, I had a power glitch here.
I know.
And so somehow or other, I don't know why, and so my desktop computer went off and now I'm on my laptop, but I had to wait till my internet reestablished. So anyway, I think you may have been talking about part of a question that I wanted to ask about how do they actively manage the pumping of that fresh water from that thin freshwater lens lying on top of the salt water when that level is coming and going. And my question kind of was, do they actively manage that somehow? I mean, I'm kind of imagining an old well system like my father used to have, where he just had this point down in the ground that had holes in it and he could suck water through it. And could they, or do they actively raise and lower the point from which they're drawing the water on a, I don't know, daily or weekly basis?
Mm-hmm. They do actively manage. They have a I don't know if the word advanced is the right word, but they're very careful about not drawing the salt water into the wells. So they know when to stop pumping. They know that there are certain times of the year, certain times of the week, et cetera, when they are should be pumping. I have a feeling it has to do with the tidal signals when it comes to the daily or weekly events. Yeah, they're very carefully managed in terms of the well fields. So on Christmas, there's one major well field. It's just outside of the main village. I tried to find pictures of it for you all, but it looks like nothing. Just one of those things that just looks like nothing. But there's a series of wells, tens or 20s of them. And yeah, they pump them pretty infrequently. And they definitely rely on El Nino events to recharge that aquifer. So, I mean, it's just very infrequent, and the rainy season to a certain extent, but it's very carefully managed. I couldn't get to a point where I was able to like talk directly with anyone. It's just culturally, it's just so hard to find someone who's in charge of something on the island. It's just almost impossible. You'd have to like live there for years, I think, in order to have a conversation like this with like, who's in charge of the wells and how do you do it? So I'm very curious about that myself, but you could tell it was very carefully managed. They have to. And I don't know if they lower the points in the wells. I think they're permanent fixtures. But they would install a new well if they wanted to go lower or higher.
Okay.
Melinda, is the population decreasing or increasing? What's the pressure in terms of the amount of water needed based on population trend?
Population is increasing. People are not leaving Christmas Island as much as they are trying to evacuate from from the westernmost atolls. So especially on Christmas, population is increasing. And to accommodate that, that is partially why that project was going on, that one I described or attempted to describe from the Australian company. So like one of their ways of dealing with this is on the island itself, they don't have the resources to try to increase the groundwater yield by adding to the infrastructure, but they do outsource these projects to Australia. The Japanese have an influence on what happens on the island, but Australia is the next nearest neighbor in terms of projects of this scale. So it's having friends in high places.
I'll do a last call for questions.
Do they speak English? Is that the main language?
They do not. The main language is Gilbertese. It's a Polynesian language. Very little. Some people speak English if they were like typically they're Mormon and they have gone on their mission trip. They will speak English. Or if they had gone to school in Hawaii for some reason or another, they spoke English. But for the most part, no. Like all of our drivers, which was like usually the closest, one of the closest relationships we were able to have with somebody on the island, our drivers did not speak any English. We still joke about how we don't even know their names. Like that's how much it was difficult to communicate. We would just like make names for them and they would respond, and we don't know if they thought they were responding to their name or not. Like it seems terrible, but it was actually pretty endearing stuff. I think they might have agreed. I'm not sure. But there's a lot of pointing at maps. I don't know if they'd ever seen maps before, but we figured stuff out. It was pretty amazing actually how much you can do without speaking the language in common. So I took that in the direction of a fieldwork perspective, but their word for white people was imatang. So we would walk down the street and all the children would say imatang, imatang. We knew that. And then we figured out that if you were Black, they would say imatang but Black. They knew how to say that. So yeah, it was just interesting, the little bits of non-English communication that came across.
Melinda, we've got a question in the chat from Joe Garbini. He asks, any risk of water usage due to agriculture? And he was wondering if there's any presence of palm oil agriculture.
Yes, there is a risk of water usage due to the coconut palms. They suck a lot of water in the areas where they're planted. And to my knowledge, there's no palm oil industry there. But I would guess that water is actually the limiting factor with that. And the lack of major port space. The next biggest industry would be fishing, and that does not benefit the Republic of Kiribati hardly at all. They have problems with like large fishing fleets from Spain and other countries coming into the international or coming into those waters and overfishing. So that becomes not their export, but somebody else's. But yeah, palm oil, I'm guessing, needs too much water and that it would not be a good investment. But that's an interesting thought. In the future, you never know. In the future, that could be something that comes up. Yeah.
Well, I would like to. I would like to thank you very much for talking with us, for introducing us both to the culture and to the freshwater issues, and to how geology is helping to understand those issues. So on behalf of the whole audience, thank you very much for both your talk and for answering these questions. I believe today we won't be able to continue kind of informal conversation after this because a number of people may want to still catch the Good Friday service. And at the very top of the chat, if you're thinking about that, there is the link to the live stream. So you can very easily slip into the back of the room by joining the live stream for that. But we'll do a round of applause for Melinda, especially people who are showing their videos there. And we really appreciate it. Thank you.
Thanks, Deanna. Thanks, everybody. Happy Good Friday.